October 2025. Perseverance. As night sky cameras capture a startling flash, racing across the Martian heavens at 60 kilometers per second, the timing matches perfectly with the close approach of interstellar visitor 3I Atlas during its historic flyby of Mars. Then, silence. Mars orbiters go dark, raw image feeds vanish, and whispers of multiple fast-moving objects and a brief green flash begin to ripple through the scientific world. The first official images hinted at something odd, behavior no known comet should show. And just as the questions began, data releases stalled. What vanished in those missing frames? And could those clues redefine everything we think we know about interstellar objects? October 2nd, 2025. Amateur astronomer Stefan Burns uploads a 9-minute time-lapse stitched from Perseverance's public raw archive. Across the Martian starscape, one razor-thin streak cuts through, steady and unmistakable. Its apparent velocity, 60 km/s, far faster than any meteor, satellite, or cosmic ray artifact ever recorded from Mars. For comparison, NASA's Parker Solar Probe, the fastest human-made object, only reaches 192 kilometers near the Sun. But here, at Mars's distance, that speed belongs only to something from beyond our solar system. Burns's analysis is meticulous. He overlays each frame against a star catalog, calibrates scale using stellar separations, verifies every timestamp. The motion holds consistent frame to frame, not a camera glitch, not a cosmic ray. He publishes everything, raw frames, code, methodology, inviting the community to replicate or disprove his find. Within hours, the story explodes. Online forums ignite. Hundreds of independent analysts download the same Perseverance frames, stacking and restacking them with custom pipelines. Some confirm the streak, even spotting secondary fast tracks. Others see only noise, accusations fly, overfitting, artifact hunting, confirmation bias. Then, at 0:03 UTC, a fleeting green flash appears in one group's processed sequence. Real emission or digital ghost? Chemically plausible. Perhaps a cometary C2 line? Skeptics argue it's more likely a cosmic ray strike or a color channel artifact amplified by aggressive stacking. But without unprocessed FITS data or camera telemetry, no one can confirm anything. Every test, signal-to-noise ratios, frame consistency, cosmic ray rejection, becomes a battleground. No raw data, no calibration scripts, just speculation and growing frustration. Is this a standard data delay or deliberate silence? Mars, for one brief week in early October, became the solar system's best observatory for 3I Atlas. 3 orbiters were tasked to catch it: NASA's Mars Reconnaissance Orbiter, HiRISE, ESA's Trace Gas Orbiter, CASIS, and Mars Express, HRSC. At a closest distance of 9 million kilometers, 75 times the Earth-Moon gap, even the best cameras could only see a faint smudge. Still, every instrument was reprogrammed for this flyby, slewing off their usual targets to track a rapidly moving interstellar speck. Each exposure was a gamble. Aim too early, miss it entirely. Aim too late, and it's gone into the dark. Every pixel mattered. Each image was a fragile bridge between calculation and chance. Days passed. No images appeared in public archives. Not from HiRISE, not from CASIS, not even the low-res Mars Express frames usually released first. Inside JPL, engineers struggled with a different challenge. Standard calibration pipelines, built for slow Martian landscapes, break down when your target is moving 60 km/s across the sky. Cosmic rays mimic streaks. Hot pixels imitate fragments. A single stacking error could spawn false companions. Releasing raw frames too soon could ignite a global frenzy over digital ghosts. Waiting too long invites accusations of cover-ups. Every frame is checked manually, every anomaly logged and debated. It's a race between accuracy and expectation. Normally, a comet's green glow is textbook chemistry. the signature of dicarbon, C2, excited by sunlight. But preliminary spectra from Mars Express and TGO show the opposite. Weak C2 bands, almost absent, replaced by carbon dioxide-heavy emissions. So how could a green flash exist without dicarbon? A contradiction, a mystery that no standard comet physics can easily explain. Was the green truly light or code from noise? Only the unreleased time-locked spectra can tell. When the first spectral data finally arrives, it stuns researchers again. Nickel, not iron, dominates the emission lines, a complete inversion of every known solar system comet. Trace Gas Orbiter confirms it. CO2 outgassing far exceeds water vapor by a factor of 10. The geometry of its plume also defies logic, a sunward jet, narrow and sharp, instead of the expected trailing tail. Dynamic models fail to reproduce it. Only a massive, dense nucleus could hold that shape without tearing apart. No measurable non-gravitational acceleration is detected. Despite visible activity, its orbit follows gravity perfectly, more asteroid than comet, and 10 billion tons of it. Then comes an unexpected twist. Astrophysicist Avibe Low backtraces 3I Atlas S trajectory and finds a 0.6% positional overlap with the coordinates of the 1977 WOW signal, the famous unexplained radio burst at 1420 MHz, the hydrogen line. Coincidence? Probably. But the hydrogen line has long been considered the universal frequency for interstellar communication. SETI researchers warn against post-hoc connections, yet the numbers keep the debate alive. And now, with 3I Atlas drifting behind the sun, the next radio window might tell us if it's truly silent or simply waiting. By late October, 3I Atlas slips behind the sun, hidden for 5 weeks. Observers on both Earth and Mars lose sight. When it reemerges in early December, 4 things will decide the truth: brightness, trajectory, tail geometry, spectral fingerprints. If any change appears, fragmentation, color shift, or motion anomaly, the mystery deepens. If not, the story collapses back to data and doubt. Science climbs in steps. Repeatability. Can others reproduce it? Multi-band confirmation. Does it appear across wavelengths? Geometric consistency. Does motion match prediction? Deliberate structure or signal? Something nature can't fake. Each anomaly climbs that ladder. Most will fall away. Only one that survives every test earns the right to rewrite the books. For now, 3I Atlas stands as an interstellar riddle, a comet that glows without the chemistry, jets toward the sun, and whispers through coincidence. Until the next data drop, all we have are the facts and the silence between them.